In this example, it reads, by More Supermarkets sales records show that the average monthly expenditure per person on a certain product was $11, with a standard deviation of $1.80. So at this point, we've already identified the population mean, mu, which is 11, and the population standard deviation, which is 1.8. There's no need to write the 0. The company recently ran a promotion campaign and would like to know if sales have changed. They sampled, so now we're looking at the sample, so the sample statistics. The sample had 30 families, so n is equal to 30. And the population found that the average expenditure was equal to $11.50. We can see there is an increase. The question is whether that increase is significant. So part A, has the promotion campaign changed sales figures? Test this at the 5% level of significance. What do we do here? Firstly, we write down our null and alternate hypothesis. Our null hypothesis is that the mean is 11 and the promotion has not changed the sales. Our alternate is the mean is not 11 and the promotion has changed the sales. We're now going to work our way through how to look at this problem. When we're talking about 5% significant levels, okay, that means we're considering the 95% ranges in our normal distribution. So that is, we would expect 95% to be between these two, which means 2.5% would be in the tails. Because we're using not equal to 11, that means we have the two-tailed tests. So if our result had been something between these two limits, then we accept the null hypothesis. If our result is outside those limits, then we reject the null hypothesis. From your work in maths methods and stuff that you have been reminded about earlier on this topic, for a normal distribution, that is where we have z is negative 1.96 and positive 1.96 with 95% of the values in between. We know then less than negative 1.96 for z, we have 2.5% of the values, which is 0.025. It is the mirror for greater than 1.96. That is what I've summarized here. So now we will carry out our test. We have our formula z equals the mean of our sample minus mu over sigma divided by the square root of n. We've got this information already. We know that the mean of the population was 11. We know the standard deviation of the population was 1.8. And we know the sample size was 30. The number that we are testing for the null hypothesis was 11.5. That was the mean that happened in our sample. So when we calculate those numbers, we get 1.52. 1.52, we can see where that sits on our axis. We have 2 here, we have 1 here, 1.5 there, so 1.52 is in here. That is inside the non-shaded area. So there is insufficient evidence to support the claim that the promotion has changed sales. Part B. Has the promotion changed sales figures? Test with a p-value of 5%. In part A, we worked out that Z was equal to 1.52. So if we worked out the probability Z is bigger than 1.52, that is, with our standard normal distribution, standard normal, mean of 0, standard deviation of 1, 1.52 is sitting here. So what we're doing is working out this area there. Using your calculator, that will come out to be 0.0643. I have drawn the graph and written that calculation down here. So, accept the null hypothesis. There is insufficient evidence to support the claim that the promotion has changed sales. If the tail area was less than 0.2025, then we would reject the alternate. As the tail area is greater than it, we accept the null hypothesis.